Hi, this is Jeff from the Ozark Mountains, that's in Missouri, in the USA. A few weeks ago, we finished up the restoration of this TRS-80 Model 4P. The one thing I lamented about at the time was the level of noise from the cooling fan. Well, this time we're going to see if we can't quiet that down a little bit, and we're going to make use of this little guy, which is a fan speed controller. Well, this was only about 10 bucks on eBay, and we'll first try it out on the bench and see how it works, see how to program it, and then we'll do some testing and some temperature probing and things inside to see how it might work in this 4P. Let's get started. Thanks to PCBWay for sponsoring this episode. They offer an excellent quick-turn PCB prototyping service, which now has a free upgrade to the 150-160 temperature range. They also offer a wide range of services that allow you to go from idea to a finished product, including CNC machining, 3D printing, injection molding, PCB assembly. Go on over to PCBWay.com/OEM to find out more. Here is our real high-techaroo test setup. I've got a 120 millimeter 12 volt fan. I stuck a little reflective target on here so I can use a little tachometer. We've got our fan control board, and this lead goes to a 12 volt wall wart. I've got a panel mount jack here, and I'm using some clip leads to connect to the board and from the board to the fan. This board comes with this lead for power in, and it comes with the temperature sensor. Can't get a hold of it there, with a lug on it for mounting. It did not come with this connector here. For the fan, I had a 4-position, which I just cut down to fit this and flip the wires around as required. You can plug a 3-wire fan into this, one that has a tack, and the tack is brought out here on the yellow wire, but this board does not make use of the tack. So I'll get a close-up on this board and the little LEDs here and show you how the programming works, because the instructions that come with it are way less than clear. There are 2 basic settings on this fan controller. The primary setting of the fan is what they're calling the bottom line speed, and really that's the minimum speed. And one thing to keep in mind is that a fan may run at a lower speed than it will start at. So find the speed that you're happy with to start with, remove power, apply power, and make sure it still starts there. What I would suggest is finding the minimum speed at which the fan will start and go at least 1 higher than that. That way you have a little safety factor built in. This particular controller will start speeding up the fan at 30C, and by default the fan will be at full speed at 70C. Now you can change the span right here. For example, if we set the acceleration width to 20 degrees C, then the fan will start at raising its speed at 30C, and it'll be at maximum speed at 50C. So we can set that too, and the settings are going to depend on your application. To adjust these things, first we're going to apply power to the board. You notice, if you can just see there, this second LED is on. This is like the normal operating mode. If I press the button once, you'll see it flash over on this side, the third LED, and then it'll start flashing the second LED. The second LED will flash for 20 seconds, and then it locks in the value. If I double click, it's going to go and flash over to the one side. Same thing, flash 2 for 20 seconds, saying it's setting that value. This setting is setting the initial fan speed. So for instance, if I go click, you might have been able to hear the fan speed up a little bit. Click. Okay. And if I just let that set, this will stop flashing. Okay. And if I test the speed here, that's about 1350 RPM. It's a little faster than I need it to be. Oops, I sped it up. The double click speed is a little touchy. I found out that this particular fan will start reliably at about 1100 RPM, which is 50% of the maximum speed. So that's where I have this set to. And we'll wait till the number 2 LED stops flashing. Okay. And if you press and hold the button, you notice the number 2 is flashing. If I press the button, it's going to 1 and 2. Press the button again, 3, double click, it goes back to 2 and 3. That corresponds to this chart. So our 2 and 3 flashing means that that span is 40C. Now I want to set it to 20C, so my fan speed will be adjusted between the sensor temperature of 30 degrees C and 50 C. So now it stopped flashing, it's programmed itself, so I'm going to hold the button down again. Okay. Double click, and it's on 3, which correlates to 20C on here. I don't know if that's the correct setting for our Model 4P. I'm just kind of guessing. We'll do some measuring of the internal temperature of the thing and see how it works. Okay. Now our speed now is about 1120 RPM. I've got my soldering iron right here. And I'm going to try to hold the temperature sensor near the soldering iron. And typically things that are temperature related, they don't react instantaneously because temperature does not change instantaneously. Yeah, now it's speeding up. 1300, 1400. 1900, it's almost at maximum now. I'll pull it a little further away. $1900, $1700. It's not a very precise way to control the temperature holding the sensor near a soldering iron, but you get the point. Our little speed control does work. Now I found there is all sorts of these little guys. Some are made for 2 or 3 wire fans, some are made for 4 wire fans, some will work with fans that can be reversed. Some have different features, like the fan can be off below a certain temperature, yada yada. So you just gotta do some looking and find the one that seems like it'll work best for your application. I think this will work for what I'm trying to accomplish. So we'll get the 4P back out now. And I think the first thing we'll do is use a temperature sensor in there and just kind of let it run for a while and get an idea of what the temperature is at various parts inside of it to figure out where we're going to put this temperature sensor. For the first test, I have mounted a thermocouple here on the power supply board at the low voltage end. I ran it around and taped it to the top of the fan, and it goes out through the one of the handle screw holes. That way it's keeping the cable away from all the high voltage stuff in here. We'll go ahead and fold this back over, put it down in place, and we'll start the memory test and let it run for an hour or so and see what the inside temperature of this thing stabilizes at. You might be able to hear the floppy drive squeak in there as this diagnostics program is running. before I powered on the computer, it was at 22.3 degrees C. It's been running about 3 minutes now. I've got the memory test on. So for the first several minutes, I will log the temperature, and I'll let this memory diagnostic program run for about an hour or so total, and we'll see what the internal temperature gets to. And then we might try a few other locations inside to get an idea of the best place to put the temperature probe. After doing some testing and letting the unit run for a few hours, I found that if the temperature sensor is clamped down to this section of the board, this is normally around 30 C when it's in operation, even after 2 or 3 hours. The heat sink of this power supply is mid 30 C, so that could be another possible place to put it. But I think I'll put the temperature sensor right under this screw. That'll work out fine. I also tried it taped in this wiring harness. That worked fine there too. And then I rigged up the fan. This is our stock fan, to the speed control board, and found out something interesting, that this particular fan doesn't like to be speed controlled. It will requires nearly full speed to start or run at all. If I slow this down more than a few hundred RPM, it won't run at all, even if it starts at full speed. So this particular fan, which is a Panaflow DC brushless model FPB-08B12L. It's an 80 millimeter by 25 millimeter fan. It doesn't like PWM, so we're gonna have to go a different route on this. And I looked around. The next closest size fan I had was 92 millimeters. It works fine with this speed control board. Other random fans I've tried work fine. Just this one in here, and that's not unheard of. Some just don't like the PWM signal to power them. So I have ordered an 80 millimeter fan, and when it comes in, we will pop it in there and see what difference it makes by itself, and then we'll try it with the speed control board. While waiting for the new fan to come in for this thing, I got to thinking about the airflow through the machine, which is designed to go in on the bottom here through this set of grills across the main board. It goes up in the corner over here, kind of behind the floppy drive bays, and gets sucked in by the fan. It gets blown into the CRT cavity and out these grills here on the top. So I set things back up again so I could run the thermocouple out with the cover still on. I clamped the thermocouple under a mounting screw on the power supply board near where I had it before. And it's been running 3 hours. It's settled in right at 29.5 to 30 degrees C. It's 21 degrees here in the basement right now. So we've got a pretty good baseline of temperature now with this fan running about 2100 RPM. So we can install the new fan and our temperature control board, or the fan speed control board, and see what happens. I used an app on my phone to measure how loud the original fan was with the case on, and with the case off, the phone is about 600 millimeters from this edge of the case. With the case on, it was 32 dB. With the case off, it was 31 dB. That's an average over 15 seconds. That's pretty close. It could be that it resonates a little more in the case, and it could be that I don't have the angle of the unit exactly as it was before. But the main point is there's not a lot of difference. I also have let it run about half an hour and checked the temperature increase. Just like it did with the case on, it increased about 4 degrees Celsius in the first 15 minutes. So the delta T was the same in either case. So I think for the rest of our experiments, we can do it with the case off, which will make things a lot easier than putting the case on and off all the time. So now I am going to take out the original fan and we will look at it and the replacement fan on the bench and compare them. Then we'll install the new fan and measure its sound level at full speed. Well, I finally got the original fan out, which is a bit of a hassle because you got to take the drive bay and whatnot out, but got this out. The Panaflow Frank Betty Paul -08 Bravo 12 Lima. 12 volts at 120 milliamps. Replacing it is this Noctua NFA8. Comes in this really fancy looking box like this. And of course I've already had this out and tested it. It does work with the fan control board. So it comes with a lot of things other than the fan. You notice the fan has rubber isolators built into it. It's designed to be quiet. I've put a patch on here and tested the speed and set up the speed control board accordingly. It has speed adapters, which are just resistors in line, and mounting screws, or even better, these little rubber isolator things here, which you kind of poke in through here, you know, through the wall of what you're fastening it to. That way you've got the fan isolated from the frame. So I will try to use these isolators here. I thought first we'll go ahead and try to get a dB reading of both fans on the bench and see what the difference is. Here is our simple test setup. I've got the fans at one end of my green mat and my phone at the other. And I'll slide the phone over so it's right in front of the fan. And I'm powering each fan with the same 12 volt wall wart power supply. So I'll get you focused in here on the phone, and then we'll start the original fan and see how loud it is. Original fan. Noctua fan. So just to start with, the Noctua fan is about 9 dB quieter than the original fan, which is quite an improvement just there. Now I'll get this Noctua mounted in the Model 4P case, and we'll see how loud it is in there. So I installed the new fan using those rubber isolators. Those are a little interesting to use. Luckily the holes in the Model 4 case are the correct size, so that worked out well. I did have to take the whole back cover off to get in to do that. After running about an hour with the new fan, the temperature is about 27.6, 27.7, right where it was before with the original fan. The noise level dropped from 31 dB with the cover off with the original fan to 29 dB with the new fan. Also keep in mind that I had modified the original fan mounting to use some rubber isolation washers, which in itself had lowered the sound the original fan made by 1 dB or so. So not a lot. So we might have improved, let's say 2 to 3 dB just by swapping the fan out. And I think the noise this new fan makes isn't as annoying. At least to me, it may sound a little different with the cover on. I don't know. But I've made a first stab at a little enclosure to put this fan speed control board in, and I'll try to find a way to mount this in the 4P. We'll get this wired in, see how it's installed, and then we'll see how noisy it is. Bit of shaky cam here to show you how the installation went. I think it looks pretty nice. I 3D printed a little case for the board. I glued the board into the case with a little bit of E6000 glue, so the board can be popped out of there if need to be. The board is stuck to the aluminum frame using some good quality double-sided tape. I figure the double-sided tape for this tie mount here has been here 40 years and it's held up, so that should hold up pretty well. Even if this comes loose, I've got all the cables tie wrapped into here, so this can't go very far or get over into any high voltage. I've still got the thermocouple on here. Everything is zip tied up into here. This replacement power supply has 12 volts out for the fan here. That was easier to adapt to than the original plug for the fan, so I just tied that back. And I've got the fan temperature sensor and the thermocouple both under this mounting screw, which is where I had the thermocouple before. So now I will put this back together and run it and see what happens. The default or baseline speed of the fan is 1200 RPM, which seems to be the lowest RPM that Noctua recommends. The temperature span is 20 degrees, so anything above 30 degrees C, it'll start speeding the fan up, and it will reach maximum speed at 50 C. I may reduce that later, but we'll see how it works like this. Well, how did we do? I'm not sure if the microphone is going to pick up the sound of the fan right now. I can hear it, the sound of the birds and cicadas and things outside are just as loud, so it's not objectionable. Now, I did notice once I got the case back on that since it's drawing air in through the bottom and out the top, the sound is a little more kind of in your face, so to speak. With the case off, the sound was coming more from the fan area back here. So that kind of makes a little difference in how we're making our measurements. It may have been better if I was a little further away. So the directionality of the sound didn't make as much difference. It's also not the ideal environment for making precise sound measurements, and nor is your phone the best tool for that, but it gave us a rough idea. Well, how did we do? Well, with the new fan and the speed control, we're between 4 to 6 dB quieter. Now, a dB is kind of a funny measurement. The way to think about it is every 3 dB is 1/2 of the sound pressure. But that's not how our ears work. A 3 dB reduction in the sound level we hear is something about 18–20% less loud. So on this, it's between, let's say, 25–30% quieter, perhaps. The sound it is making is not as annoying to my ear, at least. It sounds softer, not as harshly mechanical. So yeah, it was worth doing. It was a great experiment. We found out those little fan speed control boards work, but they don't always work on every fan. So your mileage may vary. Is it worth doing if you have a fan that's not really objectionably loud and is working fine? Probably not, but this was a fun experiment. Let me know what you think. Thanks for watching, and thanks for everyone who helped support the Hey Birt channel through Patreon and other means. It's greatly appreciated. If you have any questions or comments, well, you know what to do. Leave them in that comment section down there below. I would love to hear from you. And until next time, bye.